This is homework 7, question 8. Question 8 asks about Poisson processing defined by the following properties. So property 1, 2, and 3. 1 asks about the number of n of t1 and t2 of the points ti in the interval of t1 and t2 of length. T is equal to t2 minus t1 is a Poisson random variable with parameter lambda t, which is equal to p n of t1 and t2 is equal to k, and is equal to e to the power of minus lambda t times lambda t to the factor of k to the power of k divided by k factorial. And the property 2 said if the interval t1 and t2 and t3, t4 are non-overlapping, then the random variable n of t1 and t2 and n t3, t4 are independent. Property 3, at a time moment t, there is no more than one Poisson point. Only using the points ti, we form the stochastic process x of t is equal to n of 0t. So question A asks about the mean of x of t. So first, Poisson, the probability of x equal to k is equal to e to the power of minus lambda times lambda to the power of k divided by k factorial. So we know that integral between from k is equal to 0 to infinity of the e to the power of minus lambda to the power of k divided by k factorial is equal to 1. So we move e to the power of minus lambda to the right side, and we get this, and we do differentiation of this equation, then we can get that it is like that. Sum of k times lambda to the power of k divided by k factorial is equal to lambda e to the power of lambda, and we move e to the power of lambda to the left, and we get this. So e as the mean of x is equal to lambda, so this equation is equal to lambda, and the variance is equal to e to the power e of x minus n square, so it is equal to e x square minus lambda square. So before we use this one and do differentiation again, and we get e to the power of lambda plus lambda times e to the power of lambda, and the left side is equal to k square as the sum of k square lambda k minus 1 divided by k factorial, and the right side can be written as 1 times lambda times e to the power of lambda, and move the k and the variance of this is equal to lambda. So e of x, the mean of x of t is equal to lambda t, and the e of x squared t is equal to 1 plus lambda t times lambda t. And this is question A. Question B asks about the correlation of T1 and T2. So the R of T1, T2 is equal to E of X T1 times X of T2, which can be written as E of X T1 times X T2 minus X T1 plus X T1. And this one can be written as E of xt1 times E of xt2 minus xt1 and plus E of x squared t1. And this part, which is equal to this, lambda t1 and lambda t1 times lambda t2 minus lambda t1. So lambda t1 is from this part, lambda t2 minus lambda t1 is this part. And this, due to x squared t1, we can written as lambda t1 plus lambda square t1 square, which is the mean and the variance. So total we get lambda t1 plus lambda times t1 plus lambda t1 t2, which is for the situation of when t2 larger than t1. And for t1 larger than t2, we can get that lambda times t2 plus lambda t1 t2. So written together, we can get this equation. So when t2 larger than t1, it is lambda times t1 plus lambda t1 t2. When t1 is larger than t2, it is the correlation of t1 t2 is lambda times t2 plus lambda t1 t2.